welcome to the fifth episode of our Unlocking Data series, where we uncover everything you need to know about personal data sovereignty in the Web3 ecosystem, including topics around data ownership in the metaverse. Well, so far we have discussed a lot around data integrity in AI, how to trade on Ethereum, and much more. If you haven't watched those episodes, please go to the I button on top and watch them. Well, let's dive deep into today's episode and introduce our today's guests, Mark Paul, who is the founder of Ethereum, and we have Jett Lee. Well, Jett and Mark, welcome to the show. Why don't you introduce yourself, Jett?
Hi, thanks for having me. Basically, I started studying around 2019 in a Bachelor of Biomedical Sciences. I am in my last year at the moment when I decided to start into getting into the world of data. I started to go down the rabbit hole of cryptocurrency around 2020 and just dove deeper and deeper until I got to the point where I started to realize the inefficiencies in data collection and storage, especially when it comes to in specific DNA data. So that's where my background is. It's in science. I saw a connection. Essentially, I just decided that I would pursue running a data coalition when I came across Ethereum, and I really, really liked what they were doing. I read through their white paper and had a look really closely before I decided that I would reach out to Mark, and I got in contact with him, and now I'm here. And I've started the process of talking to people, and it's quite interesting how people realize that DNA is so valuable.
Yes, hi. Thanks, Jett. First of all, man, thanks for joining. We had a few chats already, so it's super exciting to have you on board and to have this discussion. So we got some really interesting questions we're going to go into today. So very excited to have you on board. So thanks for coming on board.
Thank you for having me. I'm super excited.
I think you already gave us a little bit of a background about your education and how you made this transition. Maybe you could give us a little bit more details about what excites you most about data and DNA data specifically, and where do you see this whole space heading?
Yeah, I think what excited me most about the DNA data that exists today is in specific the DNA sequencing that exists. We have access to such amazing technology, especially like in the last 10 years. We've gone from having to pay, the first DNA sequenced was about, $1 million plus, right, to sequence that one genome sequence. But we've gone from that to about $1,000 to have your full genome sequence, and $100 for a short tandem repeat sequence. So that's what excites me the most, is we have access to having our DNA data at the moment. The problem that exists, which also excites me because I'm here to solve it, that's what I believe I'm on this earth for, right, is that we don't have the right facilities and also the right structure and security to store that data. I don't believe that the entities that exist today are storing it in the correct way and treating the data in the correct way and treating the people in the correct way. So therefore, that got me really riled up and also excited to solve this problem. And that's kind of what excites me today, and helping people control their DNA, which essentially is them, right?
Yeah, absolutely. So, a bit of background about myself as well. I was involved in the DNA tech space about 6 years ago. And as you were saying, we witnessed that as well, right? So it's much more affordable now to sequence your data. And therefore, we're going to probably see these cost efficiencies even further increase, making it even more affordable. And what's going to happen then is we're going to see this massive unlock of DNA data at some point very soon. And it's very critical now that we address the issues around storage, access control, ownership. So yeah, it's a very exciting space, mainly because of the value of the DNA data as well, right? It's so valuable.
Yeah, and it's something that can't be lost, in my opinion. Once you sequence your DNA, that data is out there. So therefore, it's a non-decreasing entity. Like, you've got this ever increasing amount of data, because the more and more people born, the more and more data that there is, right? There's more and more DNA to be sequenced. So eventually we're going to get to a point where we need somewhere to store this data, and it has to be moral, and it also has to award the people that give this data for certain research to have the ability to choose what is done with it, right? So I don't believe that everyone has control over their data at the moment. In my opinion, I think that large corporate companies and large privately owned companies have majority of control at the moment. And yet, I agree, it's incredible that it's getting cheaper and cheaper to sequence it. I mean, Moore's law, right? The more and more advanced our tech's going to get, the cheaper and cheaper it's going to get. I have an opinion that we're moving from a second gen of sequencing, right? I think we're in a shift phase into our third generation of sequencing technology. We definitely are coming into that new phase. So yeah, and yeah, it's exciting.
Yeah. All right. So Jett, I thought what we'll do is maybe we'll take a step back, and maybe for our audience who might not be familiar with DNA data, could you maybe just cover at a high level what DNA data looks like? What are the uses for it? Like how and who's basically interested in this type of data?
Yeah, so DNA data is basically a code. It's a natural code that bodies produce using proteins. It usually sits in the center of our cells. So we all have cells that make up our organs, and it usually sits in the center and codes for specific proteins. Those proteins end up making up who you are. That's your phenotypic expression is basically what we can see from the outside and also on the inside, right? So diseases can arise from whatever that code descripts or scripts, right? So therefore, problems in that code can be very valuable data. So therefore, if we can get access to that code in the research field, they can work backwards and kind of describe what a situation would look like if we had to treat that specific disease. So in essence, DNA itself is made up of nucleotides. Those nucleotides are just little building blocks, and we can identify what they are, but by kind of sequencing it and going, okay, this nucleotide is an A, that's a C, that's a T, and that's a G, and we go along it, and it's just a little robot kind of thing that just kind of picks out what each one is. That's from a high level, right? It obviously is more complicated than that, and there's a lot more to it. In terms of sequencing, there's different types, and also different tech does different stuff. But yeah, in essence, we're just running across it. It's like a straight line. It actually can wrap around the Earth 3 times, so that's how long it is. But we can kind of just go along it and say, okay, that's A, that's T, that's C, that's G. One of those nucleotide changes in the wrong way, and we kind of get a disease or a phenotypic expression or an oncological disease, which is cancer. We can get multiple amounts of disease. But yeah, that's kind of who's interested, right? It's research centers, pharmaceutical companies, anyone looking to treat this disease.
Yeah. So, okay, so there's a question I have that I've always kind of wondered as well. So is DNA data immutable? In other words, let's say I sequence my data today and I get my entire genome sequence. Yeah. So in other words, let's say you were to sequence your entire genome today. Is it a changing data set, or is it a data set it's immutable?
No, so the DNA is able to change over time, right? So it's not a fixed asset, right? Or in a way, and I do consider DNA data an asset. It's not a fixed asset. In a way, DNA can change over time due to there's multiple amounts of reasons, but it can change due to environmental causes, right? If like we all know skin cancer, that's an environmental cause. That alters the DNA through damage, through sun rays, but it can also alter naturally. Our DNA actually does mutate over time, but it can mutate to form what we call nonsense mutations, which don't actually have an effect on our bodies, and you don't know that it's mutated, but it has in the background. So once you get your DNA sequenced, if you sequence it in 25 years' time, it most probably could be a bit different. Like it's not a fixed asset.
Yeah,
Definitely
no, that's quite important to note, because if you look at how big the storage that's required to store DNA, what we're looking at then is, you can't collect it once and forget about it. We almost need a way to continuously store this asset, right?
Yeah, 100%. The problem that exists today is the cost price, right? So the cost to sequence your DNA can be upwards of $100 to about $250, depending on what you're sequencing it for. But that definitely is something that needs to be addressed, because it does change over time. But if someone's getting the DNA sequence for a specific disease, if a pharmaceutical company is interested in someone that has a specific skin pigmentation or has a specific phenotypic quality or trait, then that DNA is normally not changed over time. It's pretty unlikely that it'll change that specific part of the DNA that causes that phenotypic expression. So in a way, it depends what you're sequencing it for. If you're sequencing it just to know what your DNA sequence is, like to the letters, then you would need to do it constantly. But I don't believe that you would have to do it constantly if you were just getting it for a specific disease or condition, because the probability of that being altered is small, very small.
Makes perfect sense. Okay, so now we've established DNA is really valuable. There's a lot of it out there, and it's getting cheaper to get your genome sequenced. And now we've established that there is a massive market for this. You said pharmaceuticals, drug discovery, research. In your opinion, what are the biggest barriers to obtaining DNA data sets today?
I think the biggest barrier is access to facilities, right? So I think most of the world doesn't have an access to a high-class facility to run a full genome sequence. And part of that being is the cost, but also just how you get the specific specimen to then sequence it. So we all know companies like 23andMe and Ancestry.com, right? They solved that problem, but the problem was they were privately owned. So then they had access to that data, and they now store that data for themselves. So therefore, they solved that one barrier, but most people don't want to go that route of using that solution because of that storage, like that giving up of private information to a privately owned company. That, I believe, is one barrier. I also believe the cost is another barrier. A full genome sequence can cost $1,000 plus, but in sense, you don't actually need a full genome sequence if you're sequencing just this particular part of the DNA. I think if there was an entity that was created that's not centralized, like the way that Ancestry.com and 23andMe are, and use the same concept of having this shipped box out and then spitting in it, shipping it back, and then that entity also gives connection between the user and the research facility, so they know exactly who's accessing it, who's sequencing it, what it's being sequenced for, full disclosure and full transparency. Then that problem is solved, and that solution that was created is now used for a better system. I do believe those are the barriers, and I'm hoping to solve that problem. That's my goal.
Yeah, no, I absolutely actually connect with you on this. This is some of not just in DNA data, but just generally, any sort of data, mainly obvious in health data, but it's not exclusive to this, right? What we're seeing is we have these high value data sets, and most of these enterprises have solved the problem of how do you collect it, but then unfortunately they hoard it, all right? And this is the whole issue of data brokers.
Yeah.
So I really feel your mission there. Effectively, the mission Lithium's trying to solve. We're trying to build this general purpose platform where we can, get rid of this need for data brokers, right? The ability to collect your data, store it securely, create marketplaces, give you ownership. So that's super exciting. So On that note, Jett, so now you look at DNA data, right? So you're interested in this data set. As a researcher in this space, if you want to get some DNA data, where would you go?
I think I think it's very important to kind of define what research you're doing, right? If you're looking at human genome data, I think most of us can kind of sit back and say, okay, where are they getting these humans? Where are they finding these people that have these specific sets that they need? And there's only one place, and in my opinion, it's pretty logical, and it's all over the media. It's just not noticed. There's one particular place that most of these big pharmaceutical companies and these large genome sequencing companies and all these people are going to, and it's the privately owned sector, right? So they're going to these companies that are sequencing these large data sets. I mean, Ancestry.com is sequencing millions of data sets every single year. And they're going to them and saying, okay, have you noticed any, and please believe me, they have access to great researchers that can identify these diseases within these data sets, and saying to them, okay, I need this amount for my N set or the data set, the amount of data that they have. I need this amount of people to make my study relevant, and also to come up to the standards of science research or scientific research, and saying, okay, do you have that? And these companies are saying, yep, we definitely do have that because they've sequenced millions of data, and then they are buying it off of them. But the problem is, and I don't disagree that they should be buying it off of them. I believe science should advance and science should definitely go forward. But no one on the back end of that, right, of that deal is getting any type of remuneration or any type of kickback for their data being used in that research. I don't believe data should just be given away willy-nilly because they own it technically now.
Yeah.
I believe data should definitely, depending on whose data it is, be paid for by that individual that donated or supplied that data. I believe supplied is a better word in my opinion. So yeah, that's my problem. And then also where they're getting from right now is privately owned entities, definitely.
Yeah.
There's no other way to do it. You can't go individuals and say, I want your data. Like it's too inefficient.
Yeah. Yeah, absolutely. And a couple of things you said there that really stands out to me as well. For me, it's very strange, right? Like we're seeing these companies, they offer you a service that you are paying for, and then you give them access to your data, they provide you the service, and then they resell your data as well. So it's just not
for more
balanced.
money.
It's crazy when you think about it. Like it's not balanced, right? There's the value is just not balanced. And I think what we're seeing now is hopefully a shift in Web3. And this is, when we're moving to Web3, we always say this: let's not take the bad practices of Web2 into Web3. And how can we create a seamless user experience? And this is, I guess, where I'm heading to next, right? If let's reimagine the system, right? Let's say, okay, cool. We're heading into a future, or very near future, where DNA is quite affordable to sequence. Like you said, we probably don't need to sequence the whole genome, just use case specific sort of sequencing. Let's say we create an ability for a marketplace for this thing to emerge, and users like you and me, users from other countries, third world countries, developed countries, they have a visibility on this marketplace. So they see there is a demand for their data, and we provide, an enterprise builds an open platform that lets the use, we ship out the syringe, we collect the saliva collector, and we can get that DNA in. What do you think are from a user experience point of view, if we were to rebuild the system, what would be the ideal scenario? Like, is it an app-based thing? Is it something that's completely handled by people else, and all we do is just provide the data, and we maybe agree to some terms of how it's being used, and it's traded, automatically?
My opinion is that, firstly, I don't specifically think it should be an app on the App Store. I believe it should be a DApp, where it's a decentralized app, and particularly that's why I'm I got really interested in Ethereum, right? Because I want to build on top of Ethereum in a way. I think it should exist in the form of a decentralized organization, definitely in that format. And I think the policies that define what that organization is should be decided by the people, right? The users are the most important people in Web3. It's not a question. Web2 was all about the corporations, and now we're moving through to Web3 and we're leaving it behind, and we're saying now the user is the most important entity. So I believe that the user should define the policies that exist between a company taking their data and reselling it, but then I do believe that it shouldn't be that that company should hold that data. That's definitely not how I think it should interact with the user. I think the user should receive the syringe, the saliva syringe, send it off. It should be sequenced. The sequence should never be stored in any data storage that we or never held for a long period of time. Back to the user should be able to obtain it and keep it in a blockchain wallet, right? Should be able to hold it in the format that they can. I'm not quite sure on the specifics just yet. And then send it, and then hold it, and have the opportunity to stake that data to a decentralized organization where they are giving up their data for remuneration. So they are receiving money for their data. It's not a one-way street. It's a two-way street between the organization that's formed and the person that's part of that organization. They're not separate. It's a joint entity. And what should exist as is a board of individuals that are very, very well qualified in that field. So as we discussed previously, data privacy, bioinformatics, science research, and then also particularly myself, I would love to sit on that board and oversee it because I have an unbelievable vision for the user. And that board should reach out to these institutions, these research institutions, and make proposals of their data, and they should make offers, and those proposals and offers should always be brought back to the user, and the user should have the ultimate decision of whether to go through with that deal. And if that deal does go through, and I would imagine through smart contract technology, they are automatically compensated for their data. So therefore, there's this free-flowing transparency from each entity, and no matter what's going on, even with that sequencing step, they should always have an ability to know who has access to their data, from down to the person, right? So down to the person that has access and is sequencing their data, researching, because what's done in a lab is pretty hands-on. I mean, you're taking that person's saliva and you are sequencing it to the point where you know exactly what that person is like, phenotypically like. It's you're opening yourself up, right? And in turn, we should always be transparent. So yeah, that's my opinion on how it should look. I think it should definitely be on Ethereum's platform because
I mean, what you just described is our data coalition, right? And
yeah, correct.
it's a DAO, and even the concept of the app that's built, that's collecting the data. Well, Ethereum's got the data collection and analytics toolkit. So it's really what you described was effectively the Ethereum platform, and I'm so glad you worded it in the ideal use case. So super excited to have you to kind of work with and build the first DNA data coalition. That is so exciting. So one thing I wanted to cover on is the importance of the integrity of the DNA data. And if you see now, I'm kind of trying to connect the blockchain space from an integrity point of view to the data space, right? So as an example, in most industries, blockchain is very interesting to the data space because it can guarantee that the data is not tampered with. And I'm guessing this is super important in the DNA space, right?
Yeah, 100% safety. I mean, we're talking about DNA, right? DNA is essentially one of the most private parts of a person's life. Like, you are essentially digging into the way that they look, into where they came from, into how they are emotionally. I mean, let's think about it, right? Hormonal balance is like a really important part when it comes to emotions, right? So how people react emotionally you can tap into what hormones are being overly expressed in a person, or what hormones are being underexpressed. So therefore, you can tap into who that person is, how that person's acting in a way. So you are essentially just tapping into every single part of their life. So integrity of that data, and knowing that data is safe, and knowing that no one besides people that you've given permission to have access to it, and you know who those people are and what they're doing with it. The integrity of that is of utmost importance to anyone, I would believe. Like, you don't want anyone knowing your phone, your address, right? When you don't know who they are. Same thing. It's your address for the body.
Yeah, absolutely. And so in Ethereum, we have the three concepts which you might be familiar with. Proof of provenance. It's to basically prove that the origin is the origin. In this case, DNA came from you. We have the concept of proof of lineage, which is access control. If your DNA is used by a certain entity, it's on chain, and you can literally trace on chain who touched your DNA from an access control point of view. And finally, is the concept of proof of veracity, is to make sure that along this supply chain, your DNA was not tampered with. From the origin, it was signed, and from the end user who's using it can verify that it was signed from the origin. I think when these three concepts come into play, it just opens up all these possibilities, man, because what you can do is you can build autonomous decision-making AI, right? Because the AI can act on the data because the data is guaranteed to be untampered with. So this is the really exciting part.
Yeah, it truly is exciting in a way that it just eliminates all the problems that exist today in the data collection space, especially with DNA. The way that I put it is, okay, you get your DNA sequenced by 23andMe. You are able to sequence it and send it off to them, and they send you back a file. You don't know if they have a copy of that file, and also you don't know where it goes after it lands at their headquarters or wherever they're sequencing it. I'm not even sure. They don't even tell me. So if they sequence it at one of their labs, you don't know that lab has then gone and resold your data. There's no knowledge. Whereas when you put those three aspects into play, you have on-chain knowledge of where that data has gone. So you can call us out. If you know that we've sent your data without your permission, you can call us out. We are open to you calling us out. That's the point that we're trying to make. 23andMe is not open to that. They've shut down countless claims that they've been sequencing data and sending it off to entities like the FBI, CIA. Like, there's so many entities that have gotten involved in this DNA data space that people aren't aware of, and keep on using these facilities, and they don't realize their data is just being stolen from their hands. That's my point. Yeah.
Absolutely. All right, so Jett, last question, and this is probably something that's close to you as well. So imagine a world where you have unlocked as much DNA data as you want. What is the first use case that you would use it on? What is the first problem that you would solve?
If you had all the DNA data in the world, the first use case is definitely organizing that data into specific diseases. And in a way, going to these research facilities specializing in these diseases and pitching them an opportunity to have an unbelievable amount of data to solve their problem, because the more data they have, the more reliable their study is, and therefore they'll take any amount of data they can get. So thus, that would be my first use case. And in a way, I'm also then making money for my data coalition users or my data coalition partners in a way, because you are my partners in that sense. When you come into the data coalition, you're one. We stand in a circle, not in a triangle. Like, that's not how it works. We'll all just make a decision, and in a way, those people are earning income. I will use it to make income for the people that join my data coalition. So therefore, they are receiving information in the research side, and they're receiving money on the supply side. So that's my first use case. It's definitely income to the user, and also income in the form of data to the research facilities. It's a two-way street, which is nice. And I'm not an intermediary, which is also great.
Perfect. No, that's a perfect answer, and I think that's a good answer to end the discussion. So I'm going to bring Annie on screen. Just want to thank you, Jett, for your time. This is really cool. We should do this again. We should do a part 2 to this, maybe the part two is
Definitely.
data coalitions. Like how are we going to structure the DNA data coalition? And we can go into specifics in the next part.
Definitely. And I just want to say thank you for having me. And also, if anyone's interested in reaching out to me, I don't know if you guys can put a link in there. I'm looking for people to have interviews with, right? To interview them regarding how they feel about their data, because I want to make the best possible experience for them. And also, if you're willing to get involved and be the first users of the data coalition, yeah, let me know. I'm looking for data.